So we haven't proven any of these derivatives, but we did our best to try to justify them. But at this point, we need to understand that these are all defined derivatives. When we come up with these expressions to differentiate, we go to our formula sheet and we use the right formula. So example 1, I'm going to differentiate this expression, and I'm going to make sure I differentiate the right parts. That's a coefficient, so that's not going to affect the derivative. This is the part that I'm going to differentiate. So when I differentiate this, I'm going to just end up with that extra 2. So I'm going to write y prime is equal to, I'm going to have that extra 2. And then when I differentiate 3x, I just get the exact same thing I started with. Except because it's base e, I have to adjust for it by multiplying by log e. So there is my derivative. Okay, I'm just going to group my terms together. So there's my coefficient. And then I just regenerate the 3 to the x function. So exponential functions regenerate themselves when we differentiate. This one here, well, I want base e. And the thing I know about logs is I can actually change the base to any base I want. So what I'm going to do first is I'm going to just rearrange this expression. So instead of differentiating that expression, I'm going to differentiate an equivalent expression, and I'm going to change this to log x over log 2. So I'm using the change of base formula and changing it to base 2 log. Sorry, base e log. Once I've done that, well, this part just reflects a coefficient. That's just something that doesn't affect my differentiation. So what I'm going to do then is I'm going to take that and differentiate it, and I get my y prime is equal to 3 over log 2. That's the coefficient part of it. And the derivative of log x, well, I can't do any power or anything like that. So I'm just going to go to my formula. Well, derivative of log x is 1 over x. So I'm going to use that one. So then I just put in here 1 over x, and there's my answer. Now let's say that I did this with the formula, with the log. Well, I could do the same thing. So I'm going to go 3, and the log is going to be 1 over x. Okay, so when I differentiate that, but because we have a base 2, I need to remember to divide by log 2. And so this is using the formula that I had above, but notice that when I simplify this, my y prime ends up being the same because all of this just gets grouped together. That's a coefficient. That's just 3 over log 2. And then we have the 1 over x part. And it works out to be exactly the same as the derivative that I had before. So there's my 1 over x. Okay, so I find it much easier to convert everything to log base e first and then do all my calculus on that. So this right-hand version is the version that I would typically and I recommend using. So this last one here, none of these we can work out using power rule or the definition of the derivative or anything like that. We have to rely on a formula. Okay, so when I differentiate this, I'm going to differentiate log. So log part is going to differentiate into, so y prime is equal to, this differentiates to 1 over x from my formula sheet. The sign from my formula sheet, okay, this differentiates into cosine. And then the cosecant, this cosecant here, it differentiates into negative cosecant x times cotan x, and that's it. There is my derivative expression.